We know that the acceleration of a falling object is equal to 9.81 meters per second squared. However, this is really only the case for a specific scenario. This is only true for objects on Earth, and specifically for objects that are close to Earth's surface. Anywhere else in the universe, this value is different. This value can actually be calculated using the following formula, where uppercase G is the gravitational constant, m is the mass of the Earth, and r is the radius of the Earth. The gravitational constant is equal to approximately 6.67 times 10 to the negative 11 Newton meters squared per kilogram squared. The mass of the Earth is equal to 5.98 times 10 to the 24 kilograms, and the radius of the Earth is equal to 6.38 times 10 to the 6 meters. You can even check that plugging these values into the formula gives you 9.81 meters per second squared for G. For this reason, when we multiply the mass of an object by the acceleration due to gravity to find its weight, we're really multiplying it by the mass of the Earth and the gravitational constant, and then dividing it by the radius of the Earth squared. This formula can actually be written in a general form to express the gravitational force between any two objects in the universe. What you might not know is that any two objects exert a gravitational force on one another the same way that the Earth does. Right now, every object around you is exerting a force on you, except none of them have a mass large enough for it to be noticeable. Looking back at this formula, you can see that if either of the two masses are extremely large, the gravitational force will also be extremely large. This is why the Earth's gravitational force is the only one that we notice. It's also the reason why all of the planets revolve around the Sun. In this formula, r represents the distance between the centers of two objects, but in the previous formula we just used the radius of the Earth because the distance between Earth's center and any object close to the surface of the Earth is not much larger than the Earth's radius. I hope that this video gives you a better understanding of how gravity works. The acceleration of a falling object is one of the first values that we're told to remember, except we're not immediately told where this value comes from. If this video was helpful, please give it a like and comment below if you still have any questions. Subscribe to the channel for more fast physics help videos. Thanks for watching.